Hello, good morning, good afternoon, good evening, everybody, and welcome to today's webinar, Requirement Traceability for Safety Critical Applications. My name is Mark Lambert, Vice President of Products at Parasoft, and I'm joined by my good friend and colleague, Ricardo Camacho, who is our Senior Technical Marketing Manager for our functional safety products here at Parasoft. We're really excited to share with you today some of the great content that we've got, talk about integrations and how you can really make requirements traceability streamlined for your software development process. But before we jump into that, let's go ahead and just go through a couple of things around Zoom and make sure we've got today's webinar going great. First of all, everybody's mics are muted. However, if you have questions, please enter them into the Q&A dialogue that you should be seeing inside of your Zoom control panel. If you run into any problems during today's presentation, or if you can't hear audio, what have you, please use the chat channel to ask those, and one of our team will be right there to help you. Now, I'm actually just going to bring up the couple of dialogues on my side here. Just make sure everybody's able to hear me okay. Could folks just click the raise hand button inside of your chat channel? Great, fantastic. Thank you, I appreciate that. Okay, so let's get to it. Let's talk about today's content and let's talk about how we can make requirements traceability streamlined for safety critical industries. Now, let's start with why we need to do traceability in the first place. It's very interesting within our enterprise IT clients. They're looking towards traceability as to how it can streamline their agile process and how they can provide feedback to the teams during sprints. And while that is very valuable and also can be leveraged, and we do see our clients within the safety critical space leveraging that kind of concepts more and more for that purpose, when we're talking about development of safety critical software, requirement traceability is a requirement. Each of the industry areas have associated standards which talk to requirements traceability and why you need it, and along with other software development best practices that we'll talk about today, like coding standards, unit testing, and so on. Now, a lot of these standards will actually talk about how you manage the requirements definition, referencing what I'm sure a lot of people on today's call are already familiar with, such as the V model. In essence, defining or breaking down our application, our requirements into subsequent levels of abstraction, or breaking down the design levels of abstraction from high levels to low levels. Typically, what many folks refer to as this thing called the V model, so kind of going down the left side of the slope where we are going from high to low level requirements or design specification, and then as we go left to right, our time is kind of the time or the project completeness timeline. And the key thing is that this isn't just a one-directional flow. This is bidirectional, meaning that I can demonstrate relationships between each of these phases, not just from the point of view of the design, but also the verification as I start moving up the right side of our V, where I'm doing testing of each of those design and requirements principles and applying traceability to verify and validate, or to document the verification and validation of the different requirements through different types of testing. Now, obviously, this you can tell is going to generate a lot of documentation. And one of the things is you want to streamline that documentation process, and this is where automation comes in, as well as the types of requirements management systems that we'll talk about today that can help you streamline that process as well. Just a little note around bidirectional traceability and really kind of reinforcing why it's valuable and why it's important. So really the key fundamentals here are to prove that a project's requirements are fulfilled, and not just fulfilled at one point in time, but understanding that those requirements may change through the process or through the evolution of the product's lifecycle, so product development lifecycle. So it's very important to maintain traceability as things change, And we know that, through good software development practices, that this kind of traceability gives us a more predictable outcome. This is actually, even indirectly, one of the goals of Agile and the test automation processes associated with Agile. What we want to do is we want to be able to get a predictable outcome by ensuring that we're doing constant validation of the implementation as we're evolving it. Specifically, ISO 26262, which we'll talk about today, we'll probably use that as the primary point of reference. But traceability of requirements for each level of the production of the product decomposition, and that this determines that all source requirements have been completely addressed. And this is what our traceability is going to give us, and this is the documentation that we need to generate. Now, I mentioned Agile a couple of times already today and talked about it within the context of the enterprise IT market, so banks, healthcare, insurance. But what we know from working with many clients in the safety critical market is that change is happening inside of safety critical markets as well. So many organizations are figuring out how they can leverage Agile development practices and integrate that into a compliance-driven development process. There are several drivers behind that, but one of the biggest ones is the growing code bases. Systems are becoming more and more complicated. Devices are now connected, so it's no longer an embedded piece of software is no longer an isolated component. It's truly connected, not just potentially to the car that it's connected to, but also beyond the car in today's connected car world. These growing code bases are often actually new code bases as well, again, leveraging examples from automotive. Assistive driver, automated assistive driver systems, ADAS systems, give us an opportunity to create completely new code bases that are built from the ground up, but are highly complex and increasingly growing. So this is driving an increased need for a modern approach for embedded safety critical development. And what we are seeing is many of our clients in this space leveraging practices from the enterprise IT world. This is done predominantly from two reasons. First of all, enterprise IT has been applying Agile for well over a decade now, so there's some best practices that can be learned from our cousins over there. But also, we're seeing increasingly organizations, especially in automotive, where they're striving to innovate and provide even more software in the vehicle. We're seeing those organizations grow by bringing in team members who had previously been working at more of an enterprise organization rather than a safety critical organization. So bringing in those practices and bringing in the technologies that those teams are able to already leverage really helps the safety critical teams accelerate their deliveries. But what we still need to do is we need to think about how can we put traceability in place, because that is the requirement of our compliance standards. So typically where this starts is this is going to start with my definition of my work items. It's going to start with my requirements, breaking the requirements down into different sub-requirements, lower level granularity of the design. Typically speaking, what we have seen historically is that many embedded software applications have been historically relatively small. This means that we do see a number of clients that have historically leveraged Excel. So actually, coming on to today's webinar, there was a question, what system are you using for requirements management? And we did see a significant mix. We saw a mix of older, what I refer to as more legacy requirements management systems, like an IBM DOORS, for example, very heavyweight, typically not very applicable for Agile practices. We also saw a number of folks using Excel. Kind of works okay for small projects, but it really doesn't scale, and automation is very difficult when you're doing it against Excel, so you're going to have a lot of manual efforts. And then we saw a lot of kind of the middle grounds as well, which is kind of the more newer, more relevant technologies. We saw a lot of Jira being used. I'll talk more about Jira as we go through today's presentation. Jira is more agile planning rather than requirements management, though. We saw Polarian, Codebeamer, kind of a lot of those kind of systems as well. So we'll kind of talk about how we can leverage the folks like Codebeamer, Siemens, and what have you. We'll actually be using examples today with Codebeamer. We're not going to talk about Excel, though. Generally speaking, my advice to you is if you're using Excel today as your requirements management system, I would highly recommend that you reevaluate that. There are a number of other alternatives out there, and we can talk about that more at the end if that's of interest to folks. But really, in today's world, you're considering that you're trying to accelerate. Excel is not going to scale to the point that you need it. So what we're going to do today is we're going to focus on kind of how we would integrate a workflow into a requirements management system. We'll use, as I said, Codebeamer as our example system here today. So once I've got my work items, my requirements defined in my system of record, I'm then going to start triggering my software development process. The first phase of my software development pipeline is going to be around, obviously, development of code itself. And here, what we want to do is we want to build in quality into the application from the start. We're going to talk a lot about testing today. We're going to show you examples around unit testing for C and C++ code, but testing itself doesn't build quality into an application. Really, the way that you build quality into an application is by ensuring that it was built from the ground up, really conforming to industry best practices that can help you prevent problems from appearing in the code base in the first place. So there are a lot of industry best practices out there. Typically, the predominant ones focused around reliability are going to be MISRA C for C code. Currently, the autos are the C++ 14 standard for C and C++ development. Then as we start talking about security, which is very important and safety critical as more and more devices become connected, we're going to start talking about things like CWE and OWASP, but they're more orientated towards web applications. So mostly what we see in safety critical, especially in embedded, is most organizations focusing on the CERT standard, which is much more of an engineering orientated standard, telling you kind of very similar to MISRA in a case of do this, not that, versus CWE and OWASP, which is more of a vulnerability or a weakness a standard saying avoid this type of potential problem. Now, we are actually running a webinar series right now, and one of the webinars in a few weeks is actually going to cover MISRA versus CERT, and it's going to talk about the differences between the two. We'll talk about how we can apply those standards for security, kind of where the overlaps are. So today we're not going to go into the details of these standards, but please watch out for emails from Parasoft talking about subsequent webinars, because if it's an area of interest for you, you'll be able to pick up some useful information there. Now, the whole goal of static code analysis, though, is all around prevention of problems. Many times people get overly concerned about defect detection through the use of code analysis, and while some code analysis rules are detection orientated in that you can find a particular defect, what you're really focused on with code analysis is prevention, stopping the injection of defects into the application. And these things can be everything from don't do this kind of construction of your objects to actually saying, okay, avoid code that is highly complex or classes that are not really object-oriented and have a lot of coupling or cohesion associated with them. So really, what we're wanting to do is to prevent those issues from entering the code base and make the code base more reliable from the start. Now, this graph here on the right-hand side is really originally from research in 1996 by Caper Jones, talking about how we typically identify defects towards the end of the software development lifecycle where they cost a lot more, but we are actually injecting them earlier in the process, right when the developers are writing the code that implements the requirements. Now, as I said, this was done in '96, so you'd say, well, we've moved on since then. Now we have Agile, now we have better software development practices. It can't be like that anymore. Well, shockingly, the research was redone in 2017, and the graph looked the same. The only major difference was now with Agile, we're doing it a lot more frequently. So really what we have to do is we have to consider how can we improve our software development process and how can we shift left the identification of the defects, and everything we talk about today is going to help us with that effort. But more importantly, how we can push down the curve so that we reduce the number of defects that are introduced into the code base in the first place. And this is where code analysis helps. I'm not talking about the kind of basic stuff that you get with the Sonar Cube. I'm talking about the deep reliability and security analysis of the code that we can get by following these kind of standards. Now, once we've developed the code, we now need to test it. Now, hopefully, when you are defining your requirements and your work items in your requirements management system, in addition to the requirements, you are hopefully defining acceptance tests. This is not always the case. This is why this is put a little dotted line around it. There are many times that we come across organizations where they're not actually documenting upfront how they're going to test something. They just document what they're going to develop, and then the testing is done. Well, that's done later, so we'll define that later. It's okay, we can work with that, but it's certainly not what I would view of as a best practice. The best practice is to define the acceptance test right at the beginning of the process when you're defining the requirement as well, where possible. Now, once I do get to the point of testing, I need to come to a decision. Am I going to do a manual test or am I going to do an automated test? Obviously, a manual test takes longer to do. It can be sometimes more intuitive if you're doing it through the front-end application. It might actually be a last resort in situations where I can't actually create an automated test that exercises a specific piece of code. I might need to manually step through the debugger and actually capture the coverage that way. But obviously, automated tests are the best way of doing this, if where possible, more repeatable, less prone to human error, and also you can run them continuously, so you can get a lot of quick feedback in the process. And the most effective way to get quick feedback is through the use of unit testing framework. So you might use something like a JUnit test for Java. You might use something like an NUnit or an MS test or a VS test for .NET code. Or when it comes to C and C++ code, Parasoft actually has our own unit testing framework, Parasoft C++ test. And that's actually what we'll be showing you today. It's designed to both create unit tests for C as well as C++ code. So there are some open source frameworks out there for C++ code, but they typically fall into a lot of limitations when you're still working with C, which is a very large amount of the code base that's out there being developed, or that has been developed and is still being developed for embedded devices. Now, we can then move further up our technology stack and start moving further up the V on the right-hand side, and start looking at how we can do more system-level testing. This is where we can start to leverage API tests. I'll talk about that more in a few moments. Testing the operation of a device through its network communication, especially appropriate, obviously, with connected devices. And then we also have the UI as well. Now, Parasoft, we have technology that helps with the testing of web UIs, leveraging Selenium, which is an open source framework for web UI testing. We're not going to go into this in any detail today. If you are interested in kind of web UI testing, please follow up with the Parasoft team, and we'll be able to kind of give you some more pointed information around that. But we're not going to go through it in any detail today. What we're going to focus on today is both unit testing, and then I'm going to talk a little bit about API testing. Ricardo will give us the demonstration of unit testing in a few moments. Now, When I'm looking at unit testing, I'm actually using that same framework for both unit testing and integration testing. Typically you're using a code level framework, and that's key. You really want the unit test to be in source because it's going to give you more fidelity with the running the code of your unit test or integration tests when you're running them on the actual device itself, because it's not just about running on host. You want to be able to run on target as well. Executing on your target gives you real data that you can cross-correlate with the data of running those tests on the host, so you completely meet your compliance requirements. Unit testing as a practice does actually give you a better code by design. If you're designing code to be unit testable, it'll actually be more maintainable, more manageable, and actually more testable at the higher levels as well. And then also you can start focusing at this level of the code around things like fault injection, boundary values. And when you're talking about compliance standards, ISO 26262, DO 178, both reference concepts like robustness testing and error guessing. And this is where automatic generation of test cases can help too. Not something we'll show you today. We're going to specifically show you how to do test associations today, but also that's something that we can address with our CC++ test product. And then another, or the last point when it comes to unit testing is because these are at the lower level of the V, it means that they're actually more granular, which means they're easier to debug and diagnose. They're also much easier to automate as well. You don't have to assemble as much of the system. So you can do a lot of these tests on host. You can use those to run very quickly regressions, as running those as part of CI/CD pipeline. You would then correlate those with target tests, which also we actually see how many of our clients are looking to leverage Dockerized pipelines to be able to execute those on target simulations as well. Moving towards the top of the V, this is where we can start leveraging system-level testing. And here, today's landscape of connected devices really gives us an opportunity to very easily start automating the testing of the system. So if you have a connected device, you can start leveraging the concept of API testing to actually start testing individual devices, but also testing part of the system as a whole, which may incorporate, not, as I said before, not just the device, not just the vehicle that the device is within, but also that supporting infrastructure that sits behind the device. This is actually where we can leverage Parasoft's SOA test product, which is an industry leader for API testing on the enterprise IT side of our business. One of the reasons it is because of its breadth of protocol support. So it goes way beyond the standard HTTP-based protocols that a lot of these API testing tools that are out there do, and gives us the ability to be able to customize it for specific protocols that are potentially being used within my subsystem. These API tests are actually really powerful as well because I can reuse those tests for doing both load performance testing of my system as well as penetration testing as well. So I can actually start using those to do fuzzing, parameter fuzzing, and expose penetration tests, as well as leveraging those within cloud-based infrastructures or on-premise infrastructures to start pushing larger volumes of data through my system to uncover performance bottlenecks. But one of the problems that I face when I'm trying to test a system in a connected world is typically you don't have access to all of the back-end systems. This is where a concept called service virtualization can come in and help. This is, in essence, a technology for simulating the behavior of your dependent components, simulating them at the message layer rather than doing a stub or a mock, which you would do at the code level with unit tests or integration tests, simulating your ecosystem, controlling its application, its behavior, its performance, its data, and using that to, in essence, create you a virtual test bed. Now, we're not going to go into SOA test or Parasoft Virtualize, which is our service virtualization technology today. We are going to be focused on the on-target kind of, or the C++ workflows during today's presentation. But I kind of introduce these two because as you start creating these connected devices and connected systems, that gives you an opportunity to test at a higher level. Now, when I'm doing my testing, one of the things that the compliance standards require is traceability to the code, and you can do this through the use of code coverage. There are different types of structural coverage metrics that you can use. Typically, when you're looking at the units, so at the lower levels of the V, you're going to start looking at things like statement, branch, MCDC, when you're looking at the higher SIL levels for your application. But as I move further up the right side of the V, those types of coverage metrics can become very computationally and data expensive. So here, as you start moving up the right side of the V, you might actually switch to more of software architecture coverage, such as functional core. Now, the key thing is that you want to be able to see this both within the developer's IDE, but you also want to be able to see that data, not just for an individual run, but you need to be able to aggregate it across multiple runs, multiple types of coverage values. Now, you may want to aggregate that data in the developer's IDE and be able to bring together different coverage from different runs of different machines and give it into the developer's IDE for a specific report generation there. Or we may want to actually aggregate it within an online reporting dashboard, which is actually one of the components of the Parasoft solution, where we're able to aggregate statement line coverage at that higher level within the reporting dashboard. So all of these testing practices are going to give me a lot of data, and that data needs to be consolidated into a centralized quality hub. And we'll talk about the Parasoft Reporting and Analytics Engine dashboard today, Parasoft DTP. We'll touch upon it briefly as we're talking about the traceability workflows. The key thing to remember here is that we're bringing together data not just from testing, but also from code analysis and from testing at each layer of the pyramid, both the test results, the code coverage, etc. Now, as I am sending that data to the Reporting and Analytics Engine, what I'm actually doing is I'm able to correlate that with the original system requirement. So using Parasoft DTP as the hub to my traceability process, I'm able to send the results from our reporting and analytics dashboard back into the original system of record. So we'll actually show you that with Codebeamer today. So I'll run through the demo workflow in a second, but what we're going to do is we're going to start in Codebeamer. We're going to create some tests, associate them with a requirement, send that data to DTP, and then Parasoft will send that data onto Codebeamer, and you'll see how that looks like against the original requirements and the test assets right within Codebeamer. Now, that gives me the ability to use the requirements management system as my single pane of glass, but I may want to have more advanced reporting capabilities, and the Parasoft Reporting and Analytics Dashboard enables me to both aggregate the data, send it onto the requirements management system, but it also gives me the ability to be able to aggregate or pull from the requirements management system and display that aggregation directly within Parasoft DTP. We do that because here I'm able to start associating static analysis results, coverage information, things like that directly with the requirement, and actually manage that and display that centrally within the dashboard. And then lastly, as part of working with the quality data, what you will find is you will find defects, right? You'll find defects in your system. But what you don't want to do is you don't want to create those defects automatically in your defect tracking system, whatever that may be. What you want to do is you want to go through some triaging process where I'm looking at static analysis as results, I'm looking at test automation failures, and I'm determining if they need to be fixed or if it was potentially a glitch in my environment. One of the things with test automation is you want it to be as stable as possible, and certainly service virtualization, stubs, and mocks, these things all help with stabilizing of your test environment. However, most of the time you're going to find a level of instability. You're going to find some tests which, for some reason or another, it's difficult to get the test environment into a stable state. And what you don't want them to do is artificially creating defects in your system, but you do want the warning lights. So what you have here is the traceability back to the original system. You've got a warning light there, and then you're able to go into the details inside of Parasoft DTP and use that detail to determine if a new work item needs to be created in the original system of record. So these are the components we need. What we're going to do today is Ricardo's now going to go through a demonstration of how these things all plug together. And we're going to be using Codebeamer, as I said, as the exemplary system for requirements management. So he's going to start in Codebeamer. We're going to look at some of the requirements that are there. We're then going to switch to Parasoft C++ test. Parasoft C++ test is actually built into the developer's IDE. So you're going to see Ricardo working inside of Eclipse. You're going to see those same requirements listed inside of the Eclipse IDE. He's then going to create a very, very simple test case and associate that test case with the requirement and test definitions that are inside of Codebeamer. And as I said, we're going to be a very simple test case. We'll see other webinars as part of our webinar series around how to actually do unit testing in a lot more detail with C++ test. We're then not going to run as part of a CI process. We're actually going to run just locally within his IDE, but that is actually what you would normally do. You check the tests into source control. They are source tests, so they're going to check in, run as part of CI/CD. We'll then aggregate the data in DTP. You'll see that, and then you'll send the results to Codebeamer, so you'll see how the results present there, and then we end up back where we started. Okay, so with that being said, Ricardo, I'm going to go ahead and stop sharing now. And then you should be able to pick up the ball and start sharing the screen. I'm going to start checking out the Q&A dialogue as well. So if folks have got questions, throw them in there, and I'll start kind of moderating that in preparation for kind of wrapping up. Okay, so Ricardo, over to you.
Thank you, Mark. So what we're seeing here is Codebeamer, and this is the project browser where we see various projects that we have. And the ones we're going to focus on is this Automotive ECU. And I also want to show you the inland Scrum template because there's a lot more capabilities to Codebeamer, and I want to point some of those out. Now, Codebeamer ALM is an award-winning collaborative application lifecycle management solution for distributed software development. And whether you're using an Agile methodology, waterfall, or a custom hybrid approach, Codebeamer offers complete transparency and an efficient collaboration between the different roles people play in the development of the product. So you could be an architect, you could be a designer, you could be project manager, a developer, a tester, and all this information, all these work items can be traced and linked and managed all in Codebeamer. So there's a lot to Codebeamer, but I'm going to focus on requirements management, traceability, and verification of the requirements by way of software testing using Parasoft. So I'm going to go ahead and open up the Automotive Codebeamer in a new tab, and I'm going to dive into this Scrum template. So this is nice that you have this template that gives you a lot of information. It helps you answer things like what is Agile, and you can continue in that form. But also what I like is that there's a lot of other templates like Automotive for ISO 262, for medical 62304, Avionics, DO 178. So there's a lot of that, and it complements Parasoft because those are the industries that we support. We support all the industries, but we support these standards. Our tools really complement each other, and there's all these features as well. So you can see here epics, requirements, user stories, defects. If you find defects while you're testing the software in Parasoft, you can then move those defects into Codebeamer and manage those and track those so you get those all fixed. There's also another view, which is the tracker view, and it gives you another perspective of how this project is organized. You see the work items, requirements, user story, task, bugs, and there's also test runs. And here are the dashboards. So as you click around here, you can see the dashboards. We see the status, releases, the sprints, and other information. Now I'm going to dive into the requirements, and these requirements are organized or they're really high level. They're like your customer requirements, and you can see that they are nested, so you can also have a hierarchy of these kinds of requirements. And you can scroll down. This is the document view, and you can produce these documents whenever you want or need. So really nice. Alright, so let's get to the actual project, small project that we created for this demo. And this is the Automotive ECU. This is the dashboard. So we can see here that we can customize this dashboard, add widgets, and put in important information that we want to view so we can see how the testing is performing. You have QA dashboard, and then let me dive into the requirements dashboard so we can see the requirements as well, where they're at. And on the far right hand side, we actually see the requirements. You have system requirements, high level and low level. So let's dive into the system requirements specification. Here we see that particular document, and we see that we have just two simple, very high level system requirements. And you see the verbiage, and on the right hand side, you see the attributes associated with the requirement. And these are highly customizable. You can add lots of different attributes to fit the industry or domain that you're working with. Now they have downstream references. So this is now the beginning of that traceability from my system to my high level. So these are decomposed requirements. And on these graphics, it's really great. You can simply click on them, make them larger so you can see here. These are all the capabilities that I'm going to need to implement for this particular ECU system. Now I'm going to take you to the tracker view so we can see that again in another perspective. And you'll also notice that we have here test runs, because I've actually been executing some test cases against some of these requirements or test cases that we'll see, and I'll show you that later and we'll see what that means. Now I'm going to go ahead and just open this up in a new tab so we can move a little quickly through here, and I'm going to also open up the test cases in a new tab. So we have the high level requirements, and you can see the architectural design, so we're another deeper level down, and the same information here on the right, the downstream. But now we actually have the upstream pointing up to the system requirement and pointing down to the low level requirement. So you have that bidirectional traceability. If the system requirement changes, you know that the high level requirement needs to change, and it trickles down through to the low level requirements and eventually down to the test cases as well. So let's take a look now at the low-level requirements. In fact, this is the one we're going to be focusing on, shall handle sensor input values. So this is one of the requirements that we'll actually verify. You can see here is the test case for that requirement. Now let's take a look at the test cases. Now the test cases have been broken up into high level and low level, and they all exist within one specification. The reason I did this, organized it this way, is just to show that Parasoft can go ahead and read and bring in all this information no matter how the project is organized within Codebeamer, and that's really important. The other nice thing about it is when I click on these requirements, you see all the information, you see the description, and in this case, we're going to go ahead and test this, and here it says we want to make sure we cover a range between -2 and 2. So we'll do a sunny day scenario. We'll feed it a 1, a value of 1, just to make sure that the test case passes. The other thing we can look at here is the steps. So you can also specify steps, things that you should do, and what the expected results might be. All right. So the other thing that I want to show you is the traceability matrix. So there's a traceability browser, and you can go ahead and load these presets, the requirements traceability matrix, and now we actually have visibility as to what that looks like. So we have the system all decomposed to the high level, some of these decomposed to the low level, and some of these test cases, some of the test cases at a higher level, and some of the test cases are at a lower level. So we can also very easily here see that this particular data exchange shall use CRC checking has not been further decomposed. There's no test case for it, so we have a gap, and we need to go ahead and fix that. And again, if I change this requirement, you can see all the things that it will affect and how it trickles down. So very important. Now, I want to show you real quickly, since I've been actually running the test cases, some test cases against this particular handle sensor input values, I want to show you the test runs so you can see those here. And I did this in order to actually provide data to Parasoft DTP. So I'll give you a glimpse of it right now. You can see here's the Codebeamer Automotive ECU. There were 29 total test cases. There was code coverage associated with it. There are a set of requirements, and there's tests and pie charts and all that kind of information available to you. So this is great. So Parasoft DTP acts as a centralized hub and dashboard that provides a comprehensive view of the state of the code base. And the testing activities being performed are also captured here, like static analysis. You can see here we have 67 violations. There's also unit testing, there's code coverage, and you can actually demonstrate full compliance traceability and productivity or progress. So the aggregation of all of this information enables you to see, measure, and be able to make sound business decisions based on the information and the health of your project. And these widgets here are actually very interactive. They're not static. You can click on them, you can dive into them. So for example, I'm going to click into these requirements, and these are the requirements for the Codebeamer. So we can see them all here. And if I click on these, this will take me back to Codebeamer. All right. And we can see that it has the success of that execution. All right, so let's get now to some really exciting stuff, and let's go and figure out how do we actually integrate this with CC++. So I'm going to go ahead here and bring up CC++, Parasoft CC++, and what we're looking at is the Eclipse is running within the Eclipse IDE, and we can run with various IDEs, and that's one of the really nice things, is that you may not have to learn some whole new proprietary IDE if you're using Eclipse, if you're using Visual Studio, Wind River Workbench. I mean, there's so many integrations here that the learning curve and productivity is basically immediate. Now we're seeing here the sensor.c code, and so this is where actually my handle sensor value function exists, and this is what we're gonna want to test. Now on the right hand side, I see that I already have those test cases that I was talking about, and I executed these again so that we can populate Parasoft DTP with a lot of information. So one of the things that also I did initially was actually go ahead and build those, generate those unit test cases that you see there. But we have a lot of built-in capabilities. For example, for compliance, so aerospace, PAC, and automotive, and we have a lot of these nice features already set up. For embedded systems, we actually run within lots of various target environments, and so I wanted to give you a glimpse here. For example, ARM and Altium and IAR. And so if there's a particular hardware environment that you want to use, run, you'll be able to do that with Parasoft, and we could also help you with anything that's custom. So you have static analysis for MISRA, AutoSAR. There's a lot of different options also available. Unit testing, so you can auto-generate a lot of test cases. And again, that's what I actually did here. I was able to simply just generate test cases, and that improves the productivity, and that you very quickly you have a lot of test cases created for you. All right, so how do we now link this, the Codebeamer requirements, and to the test case and create test cases? So you'll notice that we have a requirements tab. So when I click on that, there's a little option here that gives me visibility it's already connected to the Automotive ECU project, and I have visibility here to the system requirements, the low level, all those specifications. And I'm going to choose the low level requirements because it gives me also another level of granularity down. It gives me the view to the test case. So for example, I can double click on the test case and I can see the test case information. So that's like really cool. Now, in order for me to create this test case properly, perhaps I want to be able to also look at the requirement. And I'm gonna just kind of organize these, put them side by side. So by reading this information, I want to go ahead, create a test case, and I also have the code, so I know that there's an input to it. Now I'm gonna go ahead and simply come here to the test suite, and I'm gonna add a new test case. I'm gonna call it test underscore a underscore sensor. And the reason I'm calling it that and putting the A is so that it shows up at the very top. Now this is the editor, and what I want to do very easily is select the handle sensor value. So you'll notice that the code's already been analyzed. We already know what all of the functions are, and we see them, and so we can select them. Now by hitting the plus, it says create the new test case for this function, and there it is. You can see it in table format, what the inputs are, and so I can start providing that information. So for example, I want a value of 1. It's going to be a sunny day scenario. Assertions, I'm not going to have any, so I'm going to remove that. And as soon as you hit the save, you can see it up here. So now it exists as a file. And well, what does that file look like? Well, the file contains the information on this table. So let's click on it. This is it. And so we see it right here. So this XML is the table information. And this is actually the test case information. So you can see here we're putting 1 to the value, and then we're invoking handle sensor. So very simple. And this is nice because you can go ahead and customize this code any way you want. You have the full power and capability and flexibility of doing whatever it is that you want to do here. So this is just fantastic. All right, so we created the test case, and we selected what function this test case pertains to, and we created the test case. So what we want to now do is link the Codebeamer requirement or the Codebeamer test case. So we're going to do that by simply, in this case, I'm going to link it to the test case. I'm going to right click and select copy ID. So when I do copy ID, I'm going to go ahead and drop this into the code here, and I'm going to add a comment, because since this is code, and you can see that I'm linking it to the test case. You can also, of course, link it to the requirement. So let's go ahead and do that. Right click, select copy ID, and I'm going to now paste it there. So that's the unique ID for the Codebeamer work elements, and that's the traceability it's done. So I'm going to save this information. And now what I'm going to do is I'm going to select just the test A sensor, and I'm going to execute that. So let's go ahead and run that. So you can see here that it's running. And the other interesting thing that you'll see is this coverage. I actually have code coverage enabled. So we're at 38% for this, and it's still running. And what I'm going to do is I'm going to show you the coverage. So here it is, one test is succeeded, and let's go look at that coverage information. You can see it here, and we can see the code, we can see all the coverage information available that's been performed. So this is really great. This is cool, and you can see all the little details. And again, this information is going to be put into Parasoft DTP. So you can see here publishing to DTP. So I'm going to also hit the proceed because there's this little report that also gets generated. So we can see some information here. The ECU project, the length of time it took to run that test, that it passed. And we have other metrics information here as well. All right, so let's go to Parasoft here, DTP. And okay, so what we need to do here is refresh this view. So I'm going to go ahead and click refresh. And now you can see that the table's been updated. We're looking at this particular test case. We can see the pie chart. We can see that this particular test case is in green. It has passed. We could look at our requirements. So there's a lot of really, really valuable information here. And let's take a look at the requirements. We see that we have the shell handle sensor input values. That's the requirement. And it's passed 100%. So that's where we're at. The other thing is that this table here is bidirectional. So we can navigate to Codebeamer, simply I'm going to click on that ID, and it's going to take me to that requirement, so we can see it here. We also are looking here at the downstream references, and so what you could now do, if you want, if you could mark this requirement as verified. But first, let's go into the test case because we want to look at the test runs. So I navigated to the test case. Let's go ahead, click on test runs, and we can see that we just ran this. It's passed. So perfect, this is wonderful. Now I can go ahead and change this so it's now verified, and I can also do that to the requirement if that's how you have it organized. All right, so anyways, this is all that I wanted to show real quickly, just to show you that whole integration. I hope you enjoyed it, and I'm going to hand it over back to Mark.
Okay. All right. So great. So you guys should be seeing my screen. I hope you guys saw the key capabilities. So we were looking inside of Codebeamer. We talked through the different requirements. We then went into the IDE where we could see that same requirement and then create a test case and associate it through the use of annotated comments. The key thing is those test cases, as I said before, are source code, so they're much easier to integrate into your CI/CD pipeline. And also, those are going to have much closer fidelity with actually the code that's run on the target itself. We didn't show CI/CD just because watching a Jenkins script run is not the most entertaining thing in the world. But obviously, you're going to check the code in source control and plug it in there. We're then going to aggregate that data in DTP, and that data gets updated dynamically, as Ricardo said. And then that data is then pushed into Codebeamer, both the data from a test run, but then also being able to roll that data up into your traceability matrix. Now, we do have time for a few questions. I actually have a couple that have already come in, but I'll kind of invite you guys to add some more in as we go. Obviously, one of the biggest things we've been focusing on today is the CC++ test product and how we're using that to create unit tests and do the traceability. So obviously those unit tests can be used for both testing of individual modules, but also at a higher integration testing as well. We can use that. C++ test does cover it all, though. So we have the code analysis, we have unit testing, we have code coverage, and then through these annotations and reporting and analytics dashboard, we're able to do the complete bidirectional traceability. It is worthwhile to point out that the product is TÜV certified as well, which is obviously a requirement when we're embedding a tool into our tool chain for safety critical, as well as having tool qualification available if you're running at those higher level ASIL for ISO 26262, or if you require a tool qualification as part of DO 178. So we'll go ahead and switch to questions now, but I would invite you to check out the Parasoft website. You'll be able to see the CC++ test product page there. There's a button that says try CC++ test. That'll engage our solution architects. They'll be able to kind of talk you through kind of what your needs are so we can help direct you in the right direction. And get you set up in your environment as well. So please feel free to go ahead and look at that. Now I'm actually going to bring up the, see if I can get the right window to pop up again here. Zoom does have an interesting interface. Okay, let's go here and right there. Okay, great. So, okay, so just a couple of questions. Some things that were coming in through the chat, I'll just bring them up for the rest of the audience because I think they're relevant. Do you support JAMA? We don't support JAMA today. It is actually planned for later this year, but if that's something that you're interested in, we're actually in the very early stages of that right now, so we could probably give you an early access to that kind of technology and that integration. Does the web interface run in the cloud or run on-premise? So both Parasoft technology as well as actually Codebeamer are available to run on-premise. We typically find that that is the desired deployment model for our clients in safety-critical spaces. So typically, yes, it's available to run on-premise. You can deploy in the cloud, but that's a deployment option when you're deploying typically within your own cloud-based ecosystem. So like if you have your own AWS or Azure account. There was a question of, can I use Jira for requirements management? I actually probably should have mentioned that when I was talking to us. I did kind of lean towards that at the beginning of the presentation. Jira itself does not actually have any requirements management or test management functionality within it. However, it does have a very rich marketplace. So if you go to the Atlassian marketplace, so actually let me bring that up and show that on my screen, will probably help. So if I just go here, if I type in Jira Marketplace, and go here, you'll actually see that this is the marketplace, and if you go test management to start with, you'll see the primary test management platforms that they support. X-Ray is what we use internally at Parasoft for test management within Jira, but there are a number of other ones. What you really want to look at when you're looking at the Atlassian marketplace are two things, and if you click on the tile, you'll actually see them. You're looking at the number of scores that they've got, but then also the number of installations. This isn't a true representation of all of the installations, but it gives you a good comparative. You're going to look for something that doesn't have just 2 or 3 people installing it. Likewise, if I go and say requirements management, and if it has a staff pick, it means that the Atlassian guys have kind of referenced it. You can see here that R4J is kind of has got the biggest number of installs here. And then some staff pick here, but these are test management tools. There are some things for requirements management for Jira, not a lot though. So typically, I would recommend exploring some of the other alternatives. Codebeamer, obviously, we believe very strongly that Codebeamer is a great product. Jammer, that somebody else referenced earlier, is another one to look at as well. I think those two are very valuable, potentially first steps. And then I think I've got one more question here, just looking at the other chat, see if any other things come in. So one question here is, does DTP have a traceability matrix? And actually there's another question which I'll tie into that, which is, can you show which requirement has been tested in DTP? So actually, I don't have your example up and running here, Ricardo, but I'll show here with version 1. So there is actually something called the traceability report inside of DTP that shows me traceability for the different requirements. And this is actually what I was talking about earlier when I said about pulling DTP and being able to pull data from the external system and correlate the data it has within its own system. Here I'm actually pulling data for version 1, but the same functionality works for the other systems we were referencing. Here you can see the work item or user story or requirement. Here you can see the tests associated with those. And if I'd had code association done, I would actually see associated static analysis results as well. In fact, actually, I might have a different system that I could show if that was of interest to anybody. Here, if I drill down into a particular work item, I can see each of the tests that are associated with that work item. I can see their test results inside of DTP, and this is the details behind the test failure. This is actually from our SOA test product, so it's actually showing message layer transactions, and actually part of the trace information there is actually to be able to show the underlying traffic that was sent to and from the REST endpoint. And then actually, let's see if I've got, I have a Java unit test here, so let's just go ahead and pick on. And I think all of these are passing. Let's just see if I can find one that's failing. Oh, it's only 24. Okay, I don't have a failing unit test, so let's just go ahead and pick on one that's passing. So here for my unit test here, I can see my source code, and I can actually also see code coverage, which I can also track for application level testing as well. So here I can see code coverage within DTP. This code coverage is obviously line coverage. However, C++ test itself is going to generate me all those different types of coverage numbers, and I can get the coverage analysis from both unit testing and application level testing there within the tool. I didn't answer the traceability matrix. So DTP has this traceability report, but the traceability matrix is something that you would be typically doing inside the original system of record. So Ricardo showed us that for Codebeamer, and that's normally where you would want that report to live, because that's the system that's managing your requirements and also the test. We're going to create test artifacts if they don't exist so that they correlate correctly. But the key thing is you want that traceability report to be able to live in the requirements management system so that you can manage change to those requirements and manage the context of those test results against those changes. So there are a number of things that we can do inside of DTP as well, but really if you're looking for the traceability matrix itself, I would recommend you look in the external system. There are some reports some things you can do from the point of view of customizing these reports to get somewhere close, but my recommendation would be, as I said, the other way around. Okay. I think that's all we have time for. Today's webinar has been recorded, so a recorded version of this will be available later. So the demo gods growling at us is there for forever. The slides are also available as well, and we'll be sending links to both of those things after today's webinar. Thank you very much for joining today, Ricardo. Thank you very much for doing the most difficult part of today's presentation. Please look out for emails from Parasoft telling you about upcoming webinars that we have going on over the next few weeks. Be safe and have a good rest of your day. Take care. Goodbye.
Thank you very much.